Cool. So what is the plan today? So today, first of all, like types of monorepos. And so we have there what we call package-based monorepos, kind of learner kind of stuff. And then we have integrated monorepos, which NX is known for, also Bazel, of course. So integrated is more of like more kind of plugin automation stuff. But we are going to have a look just at the high level of those. Here, obviously, there's also like PNPM workspaces, Yarn, NPM workspace, and that stuff. So we will actually use that a bit today. Like this will be the focus. But this is kind of what, like, there's a feature in the integrated monorepos, which I really like. Obviously, I work at NX. I'm part of the co-contributor there. So a part that I like here is automation around it. And so you can basically create so-called generators that allow you to kind of scaffold a lot of code, not just like the initial like code-based setup, but rather actually also as you go, like add a new feature in React, like add a new component, for instance. So that it will be very easy. And that is something that can also be highly beneficial for a package base. And so that's what I wanted to try out today. Like once we have a look at what these do, explore generators in an integrated monorepo, and then apply in a package-based one. Obviously, we want to create first a package-based monorepo as well. And then basically apply this generator. So there's quite a lot of things to do. I have maximum an hour and a half allocated. Hopefully can go and do it quicker than that, but we'll see. All right, so let's get going. And let me actually go ahead and create such a new workspace. So first of all, what do we understand in terms of package-based monorepos? Now, let me quickly go to the docs of NX, because that's where I wrote an article that explains all these type of things. And so you have basically these two differences. You have the integrated one. There's also a video which I created, a small one. But basically integrated monorepo, let me see actually what we wrote. Okay, there's single version dependency, define the root, like some tools are being kind of wrapped. Yeah, and this is the part which I want to actually go and look at. So basically it's pretty straightforward to add some new project to it, because there's a lot of tooling around it. While the package-based monorepo is much more, if you want, loosely coupled. So you just create a collection of package.json files wrapped in a folder, of course. And most of the goal there, specifically also, for instance, if you take a look at Lerna, is to publish those packages. Creating a package inside the repo is just as difficult as spinning up a new repo. Yeah, because, and this, the tooling is mainly the main thing. All right, so let me go ahead and actually just create one. So how do we get started? Like, let's start with the first part here, which is explore the integrated monorepo setup, so that you get a feel of what I intend with tooling. And so I have a local fresh build of NX here running. This runs on my local server. So I'm using Verdasher there. So right at the cutting edge. So let's create here a new integrated repo. All right. So this gives me a couple of options here. So you can see we can also generate a package-based one to get started. We might do that afterwards just to be faster, but I'm currently interested in to integrate repo. And then we have some presets. Let's actually go directly with the React one, because we save some time. And so let's say demo app. This will be my React app. What do I want? Like do a Vite or Webpack. So let's go with Vite. Just CSS. I don't need cloud caching right now. So let's get that new workspace set up. And you can already see the setup here is basically choosing a bunch of options. And this is not uncommon. Like even with like other types of toolings, you get that out of the box. Like for instance, when you use the Vite CLI, it will ask you a couple of questions and then set up Vite for a React project, for instance. So it is still pretty normal. All right, so we have our integrated repo. So let's get that up. Let me switch to a new screen here. Cool. So what we have here, as you can see, we have already a bunch of different things set up. That's one property of an integrated repo, for instance, that you get all this tooling pre-set up. So you don't have to worry about that necessarily. So what does that mean? For instance, here we have like a React application. It has already Vite config that has been set up for us. Like this is stuff that otherwise we would need to do. As mentioned for the initial scaffolding, some of the stuff Vite might be able to scaffold for us, so we don't have to do all of the stuff. But we still would have to kind of go through that and create it and set it up. And so this is already given in a Monorepo. Now in a Monorepo, this is now an app here, what we have, but what I would want to have probably is in that app, have a library that I bundle in. And so here we have already a libs folder. Don't necessarily have to have a libs. You could also call it differently. Like often it's called packages. And so to generate, for instance, a new library here in X, you can just do something like React library, and let's call this, I don't know, people. Right, so this is such a generator that automates that stuff. And I want to do that same thing for the package-based afterwards. And so here you can see now I can just like say, I don't want to build the library necessarily because I'm just going to import it via TypeScript. And so now I have here my people library again generated. And the advantage here is also the generation is uniform, right? So if I generate a second one, it will be exactly the same setup. Granted, obviously I choose Node again. There's also a bunch of other stuff set up. So for instance, here in the path, I see already it has this this kind of NPM scope set up for me. And so now I could go, for instance, to my demo app and just import it there. So I could go here from this one here, and then let's see what that exports. Here it has a people export. And so here I could just do this, right? And so why is this? So if I go here, now we are in that people library again. This is because it also did generate for me already a React library. It configured it for me here, and then it exposed it to me here down in that folder. Right, so there's a lot of stuff that is being created for me just out of the box. And so I can just go ahead and straight use it. So that is an integrate repo. And now what I want to do though is create a package-based repo. Now a package-based repo is where I don't have all that stuff set up. For instance, let's search and go to React. And so here, for instance, this is a monorepo, right? And so you see here packages, and inside here we have all the different packages that React creates and publishes then to NPM. All right, so here you see a version, you see all the things in here. You see the build scripts, depending on whatever build is being used here. For instance, Webpack is being used. So this is all, like for every package, you need to set it up on your own. What does React actually use? Oh yeah, they used here the workspaces property to link to do the local linking, because that is another thing here. They use Yarn, so they use Yarn workspace probably. Because obviously if you have a package here and the package, like they depend on each other. So you have like one import like I did here that imports, one package imports from another package. You need to have a way to resolve this, right? And so in this type of integrated setup, and this is specific to how NX solves this, it does it via this path mapping over TypeScript. But you could totally do it differently in the sense that you can set up these NPM workspaces or PNPM or Yarn workspace, like all of them have that, where you give it in a package JSON. This is the top level package JSON. You give it that workspaces property and make it a bit bigger. And this tells basically NPM, whenever you build something or install a package, that it might find it locally. So it can go ahead and find it locally basically in your workspace. So actually, let's go ahead and create one of these. Now I could, again, use a generator. Like in NX, we provide the ability to set up both of them. Where did my terminal go? And so I could actually go ahead and do the same as I did before. Obviously, this is now package-based repo. And I can choose the package-based approach. And you will now see we have fewer options. And this will go ahead now and set up such a package-based approach with NX. Because NX, you can also use it with the plugins that we have just seen in an integrate one. But I could totally also just go ahead, create it on my own, basically, and then add NX on top of it. All right, so now we have it, and let's see what we got here. And so now we see we have the packages one, and this is just a setup that NX provides because it's the most common thing of how to set up such a package-based monorepo. You see there's really almost none of the plugins, like there's no plugins at all. There's just NX here. There is Prettier installed because that's kind of useful regardless of the monorepo setup. And that's already it. So I think we can actually use this to get started so we don't have to do everything from scratch. But if you wanted to do it, you could just basically set this whole folder structure on your own. And then if you want to use NX, just do npm install NX at latest. Or actually at latest. Almost forgot the command. So something like this. And then NX would kind of figure out, oh, okay, you're on a package-based monorepo and add itself on top. Why that is useful, check out our docs. So if you go there to the docs, you will have a getting started tutorial here, basically. That will give you the package-based repo setup and the integrated repo setup, and so you can just go through. But the main reason why you would want to add NX is for speed. That's all. Right, and actually what I did is I wrote a blog post a while back on how to set up a monorepo with NX, but starting from a PNPM workspace. We can actually go and use some of these things here. So what I do here is I use PNPM. Now in our case, I use NPM. You can already see that what got generated for us is here such a workspace property. And the workspace property, again, is for npm to know how to locally link the packages. And then here, what I did is basically here I have apps and packages. And I used a remix application in this case on how to, where I import basically the libraries and stuff. Now, what I want to do more is create a library actually, because that's then how we can automate some of the things. Let's create a small, simple React library. And we do it by hand, obviously. So here, let's say we have shared UI. The first thing which we want to have is a package.json, of course. And so the package.json, let me just copy that over so we get some things a bit. But this is like what our actual library could look like. So this shared UI. Usually a version, you don't have it if you don't publish it. Now, if you publish these packages, you definitely want to have a version, and you want to also have the whole version management about like increasing the version number as you like. You want to have basically a whole publishing process, which could be done with Lerna. Change sets, I think, is another one. Release it. There's a couple of them that you can use to kind of automate some of the stuff. Now here you can see I just use TSC, which might be fine, I think. Let me see here. Let's install the latest React version. Let's leave this for now. Like this would be the build output and wherever someone else could then reference the files. I think it should be good for now. Now, obviously, what we also want to create here is an index file. So usually you have an index.ts file. This is kind of the public API of the library, right? And so here you export whatever you need to export. You can see how it already kind of proposed some stuff here based on previous projects. And so in my case here, let's see what did I create here. I have shared UI. Is there a button somewhere, something I created? Yeah. Let's just do some copy and pasting so we have less stuff to type. So here I could have a button, which I export here. I don't think I would need this one, but I remember some weird behavior in compilation later, but let's see. And so here I would just export that button so that everyone outside can use it. Now there might be stuff that is just internal, right? So if you have here a more complex library, it could totally be that I have just a couple of like components that live within that library, but not outside of that library. We obviously also want to have something to compile. So since this is a TypeScript project, we need a tsconfig. And so this is what I created back then. Let's see whether it is still valid. I wonder what this weird overlay is, because it prevents me from clicking and creating files. So we have here tsconfig JSON. And this is also, for instance, something which you can see, like, there's a lot of manual steps here, which before in the setup that we had with the integrated monorepo. So in this monorepo, I didn't have to create all that stuff, right? So you can see, though, since this is all generating TypeScript stuff, we have some tsconfigs down here. And this is even kind of optimized because there's a tsconfig specifically for test files, so that test toolings can leverage, like, use this one, but it extends still from the main one here, which has like the main compilation options and stuff. All right, so you can see this is all set up for me, and it didn't just use these references to reference all of these different ones that are specific to the actual code part, to the testing part, and then a more generic kind of reuse part. So this also makes sure that things like VSCode and other editors properly pick up the types and everything. So hopefully we are lucky with that and we don't run into similar issues. Use CommonJS, but I think it's fine. We're not really interested into that right now. So it could be good. We actually need to install stuff. Now let me just run npm install here at the root of my monorepo. And so this should install now everything in the packages. If I go to the package log file, we should see, so here you can see, here's the shared UI subpart. So this is the package log, so it means that workspaces has been recognized properly. And so now we have a local package that has been deduplicated into the node modules directly. So we don't have any node modules local. Now for running the build within a single project in an npm workspace, there's actually a syntax for that. I completely forgot. Like, for instance, for pnpm, there is a filter method. So you can basically always at the root of your workspace launch the command. For instance, if you want to build shared UI, right? We would just launch pnpm-filter my shared UI project and then run build, which is its build script here. And I would run just this one here rather than having to cd into that folder, run the compilation there, and then jump out again. Now for pnpm, I actually don't remember. Sorry, for npm workspaces build single project. I believe there is a syntax that allows you to just do that. There definitely is. Run test, exactly. For instance, this one here with -- workspace. So if I run npm run build -- workspace equals, and workspace would be the project, I guess. Yeah, it would run the build of this button API here. And this would then create the CommonJS output, right? So we would see it here. And now we could then go ahead and link that in another library, for instance. But my main goal here is not to necessarily go through how package-based monorepos exactly work. You can read this up best by following along in that guide here, because that's kind of a different topic. Like, that kind of goes deep into how the linking works. What I want to do is more the automation part, because we have seen now, we have set up this library. It's quite like a simple setup. And we could actually first play around with how Zap works, because I'm curious, never tried that out. And then basically create a local automation such that we can create new libraries much quicker. Because the whole point about having that automation is to basically have consistency, right? So if your team member creates a new library because you need one, it shouldn't be like, oh gosh, now I need to go and figure out and copy and paste and delete code and rename variables. That is very error prone. So we want to avoid that and rather go ahead and have some automation around it. So you could obviously create node scripts as well, but it is an easier way as we go and see in a bit. Let me first, though, have a look at how Zap works, because I'm curious. All right, so this is what you would use to compile it. So let me see. I'm actually going to add this at the top level because in such a package-based monorepo, like an integrated monorepo, usually, I say usually because it depends on the tooling, you have a single version policy. I think Bazel follows that and NX follows that. So single version policy means that you have all or most of your packages at the root. So you have one package.json with all the dependencies for all the projects in there. And people are kind of scared by that, but it has a couple of advantages. For instance, all use the same React version. So you don't have kind of weird version mismatch, specifically also with TypeScript, like version mismatch kind of issues, which could totally happen here, especially if you start sharing code. Because if you start, for instance, having a second and third library, and they start sharing code in between, and some of them just upgrades and not all of them, then basically things might break in weird ways. So that is being avoided in a single version policy setup. And now in the typical package-based monorepo setup, that is not the case, where every package has its own dependencies defined, but you can also just define it at the root level, and so it would again follow back to such a single version policy. And usually for common things such as tooling, you might want to do it like for TypeScript. You could theoretically also do it for React. I would totally suggest to. All right, but now we basically have ZAP installed. Is it TSUp or ZAP? So let me install this real quick. And let's understand how we can use it. So it looks like you give it just the files, and then the files are written to the dist folder. You can bundle them in one go. Oh yeah, we can basically just... This looks nice. Super simple. And so if I go in here, I could now theoretically go ahead and just say ZAP index.ts. And so if I remove npm run build workspace shared UI, I get the build in an index.ts file. So now we have our library. We have the setup that we wanted to have. Now what we want to do is to go ahead and automate that setup. So we want to create a second library and have it set up in a very same way. Now it's super basic, as you can see here. So it shouldn't be hard in terms of the setting up, but it should convey the mechanism that I'm going to use. And I'm actually curious whether it actually works as well. So we basically explored generators and integrated monorepo. The generator here was when I launched basically the npx NX generator at now or React, which is a plugin. And then the generator was lib, and I said like shared UI or something like that, right? So when we did that in the integrated monorepo, it automatically created the library for us. Now I want to have something similar for my package-based monorepo. And there's one thing that you can do in NX, which is a local generator. And so if you go here in the local generator setup, this explains how you can use such a local generator to automate stuff. And this is basically if you want to create, not rely on the plugins that the NX provides out of the box, depending on what setup you use, but to create your own custom generator. So for instance, if you have a custom way of generating a library, you could use this approach to have it. And that's what we want to do. So first of all, we need to install NX plugin. And so this would be here at the root of the package project again. This is the dev dependency. Cool, so now we have the plugin installed. Now the next thing would be to actually generate one of these. Now I'm curious whether this actually works. And this is where we might run into some of the road bumps. And so now, since we have NX installed already, so we have here NX, right? We should be able now to generate such a plugin. And we want to call this automation. Let's call it tooling. So now we have the tooling set up here. So what happened here? Oh, we got also an end-to-end test. I wouldn't have needed that one. Let's actually delete that. So there's even end-to-end tests coming along to test your tooling setup, which is totally recommended if you use this in your company setup, but it's not something which we want to explore today. It did also set up Jest. That's mostly because probably we have here some spec files as well. Yeah. So what do we get here? Maybe at a high level, how do these generators work in NX and the ones we're using? We have, this is what we got here is a plugin. And the plugin usually comes with, let's say an NX plugin, comes with executors. And I don't go too much into detail because you can look this up into the docs, but these are kind of wrappers around npm scripts. So what do I mean with that? If we go back to the default NX setup, you don't usually have a package JSON in the library. So let's go to the app here. You don't have a package JSON. You can have one, but you don't have to. Because most is managed here in a product JSON, which you can see kind of like an advanced or like a different package JSON, but with more metadata around it helps NX kind of figure out what it needs to do. And it can leverage that metadata to provide more option, more tooling around the stuff. So here, for instance, these would be equivalent kind of like the NPM scripts. And if you open up, for instance, the build here, you see the executor, which I just mentioned. And this is simply this NPM package, which we have installed in this monorepo setup here of NX, in this integrated monorepo, has a function that's called build, and that's what is being run when I run build. And then it has a bunch of options, basically, that function can take as input and basically do some different stuff based on what you give it. And this is kind of the concept how it works. Here, for instance, you see an executor for serve, which is a dev server, which it lives in this now Vite plugin here, and so on. And so this is why we have here an executor as well. Now we are not going to use it because there's no need for us in this specific case. What we want is the generators. And that's the next one. They also come always packaged with the plugin. The generators are code mods. No, not code mods really, but like code generators, yeah. So scaffolding. And this can be scaffolding like for the initial package, like for the initial setup of your project, but more often it's like incremental generation. For instance, what we did here when we generated this library, right? What I used is the generator command here. So I used like that G command that I pass to NX. I give it the package name, so the NPM package name or the plugin in this case. I give it then the function or the generator name, which is lib or library, and then all the options that it needs. And this can be multiple ones. They can also be asked at like whenever I run this, right? So for instance, if I have like here contacts, and I can pass here the dry run, which is kind of a mechanism built into those generators. And then you can see it starts asking me a couple of options. So what you want to bundle it and what you use for bundling and stuff. And then it just prints out what it would generate. Now, I've used dry run, so nothing happened actually to the file system. But you can see how this works. So I generate new things with it. But similarly, I can also say, for instance, I have this people library here already. I want to add stuff on top of it. Generate a component into an existing library. So this can be from super simple to extremely complex, right? And this is what we are interested in. Like the executors is not so interesting for a package-based monorepo because in a package-based monorepo, you want to control everything into your build scripts here, right? So you have an NPM script and everything is kind of packaged into this, even though you could actually mix it if you want. But what you don't have is setting up such a new library. And so this is what I wanted to explore. Now here we got already a generator created that's called tooling. And let's use it for now. And you can see here kind of the structure of it. Now there's a bunch of different things in here, which I'm going to just remove. So you can see, like, this is mostly to show what options you have, like a sense of adding to an existing NX project configuration, adding files. Now these are things that we might need, but we don't necessarily need this one here. We also don't necessarily need here the normalizing. The normalizing is just whenever I get some options in, I can go and do some processing on top of it. We don't need that right now. So let's just remove this, or let's comment it out first. And we have as add files. So this is definitely something we need. We need to generate files. So let's leave it as here. But let's just log out. There is a logger, I think. Yeah. So Novel Dev Kit, by the way, is where this kind of developer kit for creating such NX generators and automation. So I'm going to use that. And so I can just do logger dot log. Hi there. Because what I want to do first is get this to run. So how can I run this? To run this, I should be able to run nx generate tooling, something like this. Let me see what name we use, test. Cool, awesome. This already worked. Perfect. So why tooling? This is now weird a bit, but like the first one is the name of our package. And as you can see here, this name is tooling. I don't know whether, yeah, this actually has a package JSON, so you can see it here. This is the entry point. And then the second tooling is actually the name of our generator, right? So let's actually rename this because it's super weird. And we tooling in create package, right? So we have the create package here. Now, one thing that we need to change as well is there's a metadata file here at the root of this is generators. And here we need to also adjust. So this would be create package, which is the name of our generator. And the folder here would be then generators tooling, and here as well. Creates a new package. This is just for description purposes. Cool. And so now we can delete this one here. We should be able to invoke this, but rather now we do something again as generate tooling, create package. Yep, works. Cool. So why does it ask these questions? So what would I do here? So it asks here, what name would you like to use? Now, here in the generators file, you might have seen there's a schema. There's a factory, and this is nothing else than our function. So if you go in here, there's a generator TS file. And at the end here, there's a function that is being exported, the default function. This is what is being invoked once the generator gets invoked. And then we have, as a second part here, we have the actual schema. Now the schema here, again, is a JSON schema file, which lists all the properties, right? So in our case, we want to have the name of the library, of course. And so this would be let's be more specifically, library name would you like to use? We don't have tags. Tags is something specific for an X. Potentially directory. We could have it. I don't think we're gonna use it right now. Like directory would be like if I want to have like where I want to generate basically my library. So in an integrated repo, you can have infinite nesting because in an integrated repo, since like specifically how an X solves it, for instance, since we have these TypeScript path mappings, it doesn't care if I have, well, let's actually do it. Let's create a new generate now React lib contacts. But let's say this is part of my CRM, for instance. So I want to give a directory CRM because I want to bundle everything into that domain area, for instance, right? So I can run it like this. I don't want a bundling. Now you can see it creates lib CRM contact. So you have one level deeper nesting, right? So you see CRM/contacts. And let's say here I could have something like, I don't know, what makes sense in CRM? Products. Doesn't make a lot of sense, but just to have an example here, you can now see I have CRM and I have contacts and products listed below it. So I could create some nice structure actually based on the first level is my domain areas of the product, especially even an application-based monorepo, and then build it up from there, right? Now in a package-based monorepo, you rarely see this because right now, for instance, in the package JSON, where we defined here our workspaces, it is just a top level. So you could go ahead and do something like this, but it comes then with other side effects in that like it would go recursively in to find other packages within your packages and stuff. So you might need to check this. What you could obviously do as well is just duplicate it like this, right? You could say CRM/star, right? And so you could add further layers, but you would have to somehow do it manually. But normally you just see one level of nesting. Cool. So that said, we need a name. Let's remove the directory for now to keep things simple. The name is definitely required. So if we don't have this one let's say, here we see the X prompt, which is what it's asking us. Let me remove this for now, just to show. So if I don't have the name, it would fail, right? It would say required property name is missing. And since that is kind of the first argument that is being passed, I need to provide it. And obviously, if it's not there, I can have that X prompt here, which is nice because it then asks me, what is the name of the library you want to use? All right. So that's for the setup. So now if I run this, let's say this is not shared UI, but like buttons, whatever. And then we'll just print out hi there because that's what we do here. Cool. Let's actually create this. Now, what I want to do is just replicate this behavior here, right? So I want to create an index.js file. I don't necessarily want to create here a button, for instance, but I want to just create a scaffold, a high-level scaffold that allows me to compile with ZAP, a new package. Might not have React in there as well. TypeScript here, sure. This could also be something that lives at the top level. Let me see whether we have it on the top level already, because the next depends on it. So no, we don't. Okay, cool. But we probably want to have it there. So let me actually go ahead and just clean this up. Have it in the package.json at the root here. What is the latest version of TypeScript? All right. Let's install this again. All right. So we wanted to build this. This still works. Awesome. Cool. And now let's actually go ahead and generate one of these. So the first thing we want to do is generate a package.json, generate a tsconfig, so a bunch of files that we need to create. Now here you can already see in the tooling setup that got generated when we created here that local plugin, it has already this file source structure, which has like, you can see like it has some variables in there, and this actually uses a templating language, which is embedded.js, I think. AJS, yeah, exactly. This gives me some throwbacks because I've been using this with a framework, an MVC framework based on top of jQuery, which was called CanJS. Exactly. Does it still exist? Oh yeah, it seems like. This was actually super powerful. So I wonder whether Bitovi, right? That was the company. I wonder whether they still have this, but it probably evolved quite a lot. So initially this was based on top of jQuery. Oh, they even changed the language model, like the templating language. And this used embedded.js, which is actually a pretty powerful one. And so anyway, this is what is being used here as a templating language. So you can pass in parameters, which you definitely need to basically set up stuff. Now, how do we invoke this? And this is basically via this add files, which I've just commented out here, or not even, where you can see here, well, it just constructs the template options, passing in the options that it got, etc. Then it calculates where to provide this. These are basically all just options that are being provided are being provided to the actual files generator, so to embedded.js, to AJS. And then it generates the files. It gives that tree object, which we're going to mention in a bit, source folder, target, so where's the project root, where should it be generated, and substitutions, which are basically those template options. Cool. So what we can do is just actually go ahead and copy these in. I don't know whether you see what I'm doing, but I'm basically, I have a hard time creating files because there are these overlays which pop up, which don't allow me to right click. So just wanted to remove and get rid of this source folder. So now we have the package.json file. Let me just copy this one here and paste it in here. Now this is one where we want to customize it. And this will be the project name that we pass in here. So we could do basically project name, which would be then a variable that we need to provide. And so here in the generator, we can actually go just ahead and define our template options. And then we'll have project name. Let's just leave it empty for now. This is the other one. Then we have the tsconfig, which is already here. I think this one can be left as is. We have the package JSON. This would be the description. Actually, let's just call this package name because project, it's always a project, but in the end, we create packages here. So this should be fine as well because we will get, like this would be the entry point based on the compilation step. This remains the same. So we don't have a lot to customize here. We want to remove probably React here because it's not that we create a React app. Now that's something that we could, for instance, optimize. Then we could say as a second flag, what type of framework you want to use. And so if someone says React, we would add automatically dependency based on the rules that you have. So if you have that React is a global dependency and not a local package dependency, then you could, basically you wouldn't have to add anything here. All right, now I think usually these files, I don't think you have to, but you can actually prefix them with template something, right? So if we go in here, you can see this is being prefixed with __ template __. Everything in the file name here, like everything that is with prefix with 2 underscores, that will be also replaced. So if I pass in here now template as an empty string, this will be just replaced with an empty string. I wonder why this is required, to be honest, because probably just such that it's not being recognized as a file rather than being so it's rather a template basically. For now, let's follow the convention that is being used there. But yeah, if for instance you would need to have a custom file, then you could create it in this way, where you can have like here instead of package JSON, you could say __ file name __, and then provide it during the generation process. And this would be then replaced. So you could also name file names as you want to have them. So the last step that we were missing here is the index.ts file. So let's just create this here. And again here. And here we can just say export your public functions or properties or whatever. Right, so we don't have to give anything else. So it's pretty simple setup. And then we can see whether we can evolve it and make it more complex if you want to. Now let's see what options we provide. In our schema JSON, which is the one that is being provided over the CLI input when you generate this, we get a name property. And so to type this, I think there's an interface already being created for us here. Again, these two, we don't have them. This is the name of the package. And I believe this is being imported somewhere here. Yeah. So normalized options, project and project root. We don't need normalized options. We can just rely on the tooling generator name here directly. But you could, I guess you can see why this might be useful, because if you have more complex ones, you might want to normalize some of the stuff. Or actually, let's use them. So we see the process again. But what happens here is basically I have a function where I do some normalization procedure. So let's move this out. We have here normalized schema. And then below here, when we get the options passed in, what we would do is basically what is here, right? So we have the normalization function where we pass in everything. And in there, we then do some normalization operation. And this is actually a useful one, which is the normalization of the name itself. So actually, let me just return here the project name, because that's what I want to return. And then we want to use that names function, take the name that is being passed to the CLI, and that names function then gives us a couple of options. So if we want to have a file name, for instance, let me see whether we can find the function. Yeah. So this is how it's being defined. So we give it a name, So it has just a pure name in it, but it also has something like the class name if you want to create like a JavaScript class object, because the class name obviously has restrictions of how you can name stuff. And so this names function already takes care of that to transform a string that you give it into a valid class name, into a valid property name, into a constant name, into a file name, because it might need some escaping and stuff. So in our case, let's just give that and say here, this should be file name. And why do I say file name? Well, because we need to generate here a directory, and the project name, I'm just thinking, because probably we can do something like, I don't know whether we need folder name as well, because the folder name would be, what would be the file name, right? And here instead, we can just really have the, I think we still want to have the file name even in this case, because for instance, if we go in the package JSON of the shared UI, if I provide something like shared UI, I might want to have something like this as output. So with dashes, because if that's an npm package, I don't want to use the casing, but rather want to maybe separate it with a dash or something. So let's go with this for now. We don't have, let me see what it's complaining about. Oh, because this extends from the tooling generator schema. Passing the options as well. Cool. We don't need a tree here. That's more for if you do want to do other operations. Like the tree here is, just to explain in the NX dev kit, that's a virtual object that allows you to do manipulation. So the generator basically, whenever you run this, runs against this tree, and only when everything is successful, it kind of persists to the file system. And that allows also to things like we've seen before in the integrated monorepo setup generator, where I could provide, let's say, blah, blah. So this is I can provide something like dry run. And dry run would then go to the same process, which I can choose, but then it doesn't affect the file system. So it just prints the console output and everything, shows me what it would create, but it doesn't create anything. And it's actually pretty handy. And the reason is because we run it against a file, like a virtual file system basically, which is that tree object. Those type of things can be done. Cool. But then we have the normalized options here, which we then pass to our generator. Let me actually look also if we need some more stuff here. There's a project directory. So this, if we pass something, then it wouldn't use that one. Otherwise, it just uses the name of the thing that we pass. Yeah, I don't think we need anything else. So we can remove this here. We can remove this one here. This would actually be, oh, wait a sec. There's a project root, which project root, that's a string. So that's where my project is being located. And the project directory here can just be, because here then we could do something like normalized name dot file name, and here, cool. So we don't need this one here. We have now project root, where this is where we want to generate all the files. And so we can now call the add files and the format files. Format files is just using prettier, which I believe we have seen before is being set up here. Yeah, exactly. So this would just use prettier than to format everything that we generate. So it's nicely formatted and all right. Cool. So let's try this and see what we get. So to review, we have the schema file. And we get here a name that we require. That is being passed then to our generator function, which we then normalize. And normalization right now is super simple. We really just like normalize the name of the project. We construct here that project root. So this is based on some utility function that NX provides. coming from that novel dev kit here. And then once we have that, we go and generate the files. And the files are being generated here via that files folder that we have already. And this is something that when we did set up this tooling generator here in our workspace, this got created for us. And then we just basically generate these files and we format them. Let's see. If I use tooling, create package, shared icons, and let's use here, actually let's here use the dry run so we don't destroy everything. That's actually a good hint here. We should commit first so we can easily delete stuff if things go wrong. So these will be shared icons. All right, it doesn't have a description. That's a good point. So this is actually also something I really appreciate. So you can see a very nicely, like a nice error message. So I immediately understand here in my package.json, I have this flag, which didn't get provided. And the reason is because we didn't provide it here. So let me copy this because it's also a string property. This would be the package description. So something just that we have a second option here. You pass that in as a flag. A description of the package. What is the package about? And so now that we have this, we also need to update here our TypeScript definition. And then we can go to our generator and probably in normalization options if someone doesn't provide any description, because we didn't define them to be description to be required, right? So right, just the names required, which makes sense. So we just actually, I think we can provide a default in here as well. Let me see. Default. Package generated via. Just so that we have something in there. Cool. Let's retry. Try run. What library name would you like to use? Shared icons. It asks me also a package. Oh, it gives me the default. This is neat. It gives me the default already directly when prompting, so I can just confirm. Or say these are our corporate icons to be used in libraries and apps. So I have description. It should have it now though. Let me see. What did I miss here? It has options. Options are getting passed in. Here we have the project name, project root. What does it say? Just let's call this project description or package description. Because since we're passing in all the options here in the template. Oh, now I know why. Cool. So let me go. Description is fine. The reason is what? Because I have them in options, but I don't pass them along here. Same for the package name, I just noticed. So we should here use options dot project name, which is the normalized one, and then description is options.description, right? We have this one. Cool. So this wouldn't have worked anyway. Let's try again. Library name, shared icons, package name. Let's just add something. Cool. So now we see we create a new package, shared icons, index.js, package.json, tsconfig. So this is exactly what we actually wanted to have. Let me commit first the changes. As we said before, this is a good tip. If you create those generators, first commit everything so we can easily delete. Add a create package. All right. And so now let's actually run this without the dry run. Because what we would get now, shared icons, our corporate icon package, the description. And so it creates our new library here. It has an index.ts file, which is obviously empty. It has a package.json, which has our names in here. It has the description that we added, has the build scripts in here that just builds the index.ts file here in this case. And it has all the other options. And so let me actually here say hi. Have something useful, because otherwise we cannot even build it. So maybe we should actually add such a function in our generator. We can actually do that. And then let me just run the npm run build, but now not shared UI, but shared icons. And so this would build and have the output. This is awesome, because now what we did is actually we created such a generator that allows us in a package-based setup, in a package-based monorepo, to just create new packages exactly the way we wanted to do it. Now let's fix this quickly in the sense of adding that function here. And so we can go back. This is actually pretty easy, because we can just go to our generator, go in our index.ts. This is not even something that we need to parameterize or something, right? So we can just literally say here function, template function or something, or say hi. So someone understands this is just this is just a template function here that can be deleted. Sample function, delete. Right, so we probably wouldn't do this in a real world setup, because we would have some components or something that we generate for whoever is using this. So let's remove this again. Let me run the tooling create package, shared icons, blah, blah. Let me just add a description. And now it creates my new folder here. It has my function in there. It has the package.json and everything, and we're good to go. So really cool. I actually didn't expect this to go this smoothly, because I never tried it before. I mean, I've used this all over again in an integrated monorepo, but not in a package-based. But this is actually pretty nice. I might not probably have it in a packages folder here, although it doesn't hurt. But yeah, I think this is pretty cool. By the way, the commands that we used to build these local packages. So I did always run npm run build workspace shared icons. If you have nx, and since we have that for the whole automation part, we can also just do something like this: run nx build and then say shared, I don't know, UI, and it would automatically find that project and kind of build it for us. Where the syntax here is like the first one is obviously nx. I use npx because in that way it just uses a locally installed package here. This would be the script to invoke in this package, right? And so if you go in here, since we have here a package, let me see, we have a package script, package.json script that is called build. It would just go ahead and invoke that, and we're good to go. Cool part is also, if you use this, the nx syntax here, if I run this again, this is cached. This is just a nice little addition that you get if you use nx in such a package-based monorepo. You get caching. So this is local, could be remote as well. So this speeds up things a lot, obviously, because if we have dependencies among packages, if a package is already built, it wouldn't run it again. And you can see that in the article that I linked in the chat, which kind of goes a bit into more the details of why you would want to have nx. Now, first thing is speed, obviously, in this case, right? But now today we learned also for the automation part. Now, the cool thing also, which I didn't even mention, but now let's try, is there is an extension that we have. And so that extension allows you to generate stuff, right? And so, for instance, in our integrated nx monorepo here, it has a whole lot of things, right? So based on the plugins that are installed, it parses those generator JSON files that we have seen in our plugin. And then basically it allows you to run a UI on top of those rather than providing everything in the local CLI. Oh, this is nice. It jumps to the actual package. I didn't notice. Didn't see this one. But basically now we can actually provide this here, like some, I don't know, hello world. So this is my package name, right? And so this now does a dry run even. And so it's nicer for those people that don't want to use the CLI necessarily, so the command line interface. They would have this basically as an extension in VSCode and also IntelliJ that's about to come. But the nice thing that I wanted to show is now this also works with the local generators that we have. And so here now we have the tooling. Now let me actually, the weird thing here is it still kind of calls this tooling. And I guess it's due to the caching, because initially our generator was called tooling. And so it might be still confused a bit. In fact, now you get the create package. And if I open this, you can now see I have here my main property and also additional ones, right? So non-required properties. So if I say here show more, it would show you the description below here. But you can now set this up in a visual way. So I can have again my shared icons. It would dry run, it would show what it creates, where it creates it, and so on. So this is actually pretty neat because so you have it for those people that don't like the command line as well. And it should also work with right click. So if I do NX generate, again, tooling package, and it would just generate it in there. Let's actually do this. Shared icons. Just go ahead. And now I have my shared icons in here generated. Awesome. I see we have some viewers that joined. Anyone has questions, or did you just jump in? I didn't pay a lot of attention to the chat, to be honest. But I think this is actually pretty cool because now you get the whole flexibility of a package-based monorepo, but you also get some of the advantages that you get out of basically that automation that comes with such a local plugin that you can run in such a generator. And now, as mentioned, the executors you probably won't use as much, but the generators are really powerful. Cool. And also, if you want to generate, like create additional generators, right? I think you can even generate those, which is actually pretty nice. Because the generator, exactly, because there's that novel NX plugin generator allows you to generate a generator for your plugin, basically, which is kind of recursive. But you can see now in that tooling project, I could say, I don't know, create app, right? You have create package. So I could say create app, and that would then create me a new generator in here to create a new application. Tiny charts starting with context. Yeah, I guess so. If you just chimed in, it might be hard. Let me quickly bring it up because it might be a nice summary to conclude this stream, because I think we're good, like in 5 minutes. So what we did is, so this was kind of our agenda, right? So we wanted to figure out, like first of all, we looked at what type of monorepos there are, and I brought up, sorry for jumping around here. But I brought up basically that there are package-based and integrated monorepos. And the best is if you go to nx.dev intro. I can put that in. It has 2 tutorials that kind of walk through of how NX implements those 2 types of monorepos. There's also an explanation of what like a package-based and integrated monorepos are, which gives some more info on top of that. But what our goal was is an integrated, like, so at a high level overview, basically, so a package-based monorepo is just more loosely defined in the sense that you have a packages folder, you have a bunch of projects within it, each one has its package.json, its build scripts, and you just then create them locally in a monorepo setup. You can locally link them, and so on, as I've described in a blog post, basically of that PNPM blog post, which I referenced earlier. So that is probably the best reference you can use to go through to kind of start with a PNPM workspace, or NPM workspace can actually be the same. But what we wanted to do is we wanted to get some of the benefits that an integrated monorepo gives you. Because an integrated monorepo has a lot of tooling around. So it's more strict if you want, in the sense that you don't necessarily have a package JSON, but you have, in the case of NX, you have such a project JSON, which is kind of similar, but not totally the same thing, right? It gives more advantages though in that you can just go ahead and say, hey, I want a new application. And those that have followed along see that I struggle today with right clicks because there's some insider release on VS Code that has these weird pop-ups which prevent right clicking. So basically what such an integrated setup provides me is all these generators. So I can just right click and say, hey, I want to have a new React application in here, which uses Webpack as my bundler. It's called, I don't know, products, right? I potentially can provide a whole lot of different setups here, like what compiler I want to use, whether I want to use end-to-end tests, a linter, like a lot of different things. And so this would then go ahead and just install everything for me. Let's choose Vite because otherwise I need to install Webpack here. But basically I just hit a button and what I get here is a new app that is products. It has Cypress end-to-end tests. So a whole setup. That's why it's integrated, right? Now in the packages, we don't necessarily want to have that, but still that kind of generation part is actually pretty cool because if I have once my setup as I want to have it for packages, I want my team members to benefit from it, right? So the whole purpose of today was to see, can we maybe leverage some of those generators that NX gives you by automating our local workspace, right? And so that's what we did. We created here such a local generator, and that's what is being called. Right, so here basically we create a package-based monorepo. We used here Zup, it's a neat library to build our our TypeScript app. So you can see here this one. And then once we had that set up, we wanted to make it easy for others to kickstart it as well. And so we created such a generator, which can just be created by basically here following that local generators tutorial on NX docs. So we had to install this package. We had then to run this command. This sets up a local plugin, which is exactly that tooling folder here. And from there, then we have that generators file, which allows us basically to define such a generator. Now, you can follow along with the actual recording, which I will upload in this in the banner that you see my YouTube link. I will upload and edit the recording of this stream. But in the end, it's nothing else than a function that is being called with some metadata that we provide, which is this function, which does some normalization of the things that you give it to the command, and then it generates files, right? Using such a utility function here, generate files, takes these files here, right? Some of them are parameterized, such as this one, right? And then just generates them. And so in the end, what we have is we can go ahead and say nx generate tooling, because that's the local package. Create package, it's what our generator is being named here. Create package. And then say shared icons, right? Then it asks me about, hey, what is this package about? I don't know, blah, blah, live stream, whatever. And then that creates me a new package with some setup already, which I can obviously define. It has the description I provided, it has the name I provided, and all the build setup. And so the whole thing is about, this can be really, like the whole generator part can be really, really useful in monorepos for just standardizing things, right? In the sense that if you have teammates, they can really easily basically get started with a new library. So Leonardo, let me see. Leonardo Matevi, hey, how are you doing? Last week I asked ChatGPT what would be a good resource for learning NX, and the bot sent me a Udemy course by Yuri. I actually don't have a Udemy course, but I have ACAD courses. I mean, the best place to go is definitely NX Dev if you want to learn about NX stuff, obviously. That said, we have a YouTube channel where we provide a lot of content, so it's NX Dev Tools, where I and my colleagues are publishing videos. We actually got 10K subscribers last week, which is amazing. Like, we were kind of blown away. But we provide you a lot of videos about things that I'm teaching here. And actually this one here, my live stream, is a way for me to brainstorm some of the new stuff. And you will probably see a video that's kind of more the refined, kind of 4 to 5 minute version of what we did today, of how we can automate such a package-based repo. So that's probably coming up pretty soon. But this is a good place. Otherwise, on ACAD, you can totally find me as well. There are some NX courses there as well. So if you want, you can check those out. Tiny Charge mentioned Huge fan of your Echo tutorials. Yeah, thanks a lot. I actually have a couple of good ideas on new courses. I just need to find time. But I have some good ideas of what can be provided there. Totally. Yeah, and otherwise we have our blog as well. Yeah, thanks for chiming in. Definitely, again, as mentioned, chime by our YouTube channel. Let me actually add it in here, because you will probably, like this video in like as a live stream, slightly edited, will be on my YouTube channel, which is this one here. So just if you want to follow up there. And otherwise, more refined videos are probably coming up on the NX DevTools channel later. So definitely subscribe there. We highly appreciate that. And we'll provide some more stuff there. Cool. Thanks everyone for chiming in. I try to do these every Tuesday as time allows me. And so, yeah, check by next week. I usually announce them on Twitter as well. Around more or less the same time, usually 8:30 p.m. Central European time. Cool. See you in the next one. Bye-bye.